Okay, so we're looking at the parabola. This is a slightly long one. It's got 13 slides, so we'll try to get through it because a lot of this is reminding from last year. Okay, so a parabola. All functions of the form y equals ax squared plus bx plus c, when you graph them, they'll form a shape called the parabola. And you'll recognize that the highest power of x is 2. And once you have that, then you'll form a parabola. And they'll either be facing up or facing down. Okay, so what are the features? Okay, so you're always going to have a y-intercept. Okay, and that's when x equals 0. The x-intercepts, and there might be, when we look at the next couple of slides, there might be 0, 1 or 2, but the x-intercepts are where it crosses the x-axis, the y-intercept is where it crosses the y-axis, but the x-intercept is when the y value is 0 and you find the x numbers. And the other feature of the parabola is called the turning point, and that's where it changes from going down to going back up again, or vice versa. So copy that down. When you're ready, come to the next slide. Okay, so we're talking about concavity. Okay, so when it's facing up, when it's going up, we call that concave up, and when it's going down, we call that concave down. And what you do is you look at the coefficient of x squared. So there's the x squared term. That number is a positive number, so it's going to be concave up. So for the second one, we look at the x squared term. That coefficient is negative, and so it's called concave down. So concave up, and last year we called it a smiley face. So when you're positive, you're smiling, and this is concave down. And we call this a sad face. So when you're negative, you're sad. Okay, copy and move on. Okay, so how do you find the features of the parabola so you can sketch it, because that's where the money is. So the y-intercept, you just simply substitute x equals 0, and you'll find that that gives you a really easy substitution, because that all that's left is the number at the back, or where the number is, that there's no x term. The x-intercept, there could be a single one or there could be plural, but you substitute y equals 0 into the function or the equation, and then you can solve it. Now to solve it, we can either factorize it, if you can factorize it, or you can use the quadratic formula. Okay, and we'll show you those two ways in a sec. The axis of symmetry is where the turning point lies. So the axis of symmetry is where, like, the axis of symmetry is where you could put a mirror. So that's the axis of symmetry. So you can put a mirror there. So the shape on the left is the same as the shape on the right. And there's a little formula that you use, x equals minus b on 2a, or you can just average the x-intercepts. So if you've got two x-intercepts, you just average them. If you've got one x-intercept, when you average one number, you get the same number. But you can't use the axis of symmetry formula. You can't average the x-intercepts when you have no x-intercepts. So this formula is useful. You can use it all the time. And to get the turning point, and the turning point is the x value and the y value, because it's a point. The x value is the axis of symmetry, and then you substitute into the function, and that will give you the y value. Okay, so when you're ready, come across to the next slide. So looking at the number of x-intercepts, okay, for instance, it doesn't have to have any cuts on the x-axis, so that's an example of a no-intercept, or you could have a no-intercept underneath. One intercept is where it's sort of what we call like a bounce. We could have a bounce over here. Okay, so that's one intercept. Okay, or two intercepts. It could be like that, or it could be like that. So you can have none, you can have one, or you can have two. Okay, so the intercepts are actually the solution to the equation when y equals 0. Okay, so copy and come across. Okay, so the quadratic formula. Okay, so we've got the general thing. In some questions it might look like that, or it might have fx equals ax squared plus bx plus c. So fx and y are the same thing, they just represent a different way of saying the equation. But the quadratic formula, which you know from your song, negative b plus or minus square root b squared minus 4ac over 2a. Now, the formula, the quadratic formula, actually has this part inside the square root. And last year in 10A, we definitely talked about it. And what this is called the discriminant. Okay, so just that little part of the quadratic formula is called the discriminant, and that actually tells you how many intercepts you're going to have. So that jumped up a bit high. So the discriminant is the number inside the square root sign. So if the number is positive, there's going to be 2 x-intercepts. If the number is positive, but it's a perfect square, then the intercepts are rational. They're nice numbers, they're whole numbers or they're fractions. So they're integers or fractions. Okay, they're rational. Now, if b squared minus 4ac is positive, but it's not a perfect square, so a perfect square is a number like 81 or 25 or 144. They're perfect squares, but if they're not a perfect square, like if the number was 11 or 17 or 99, they're positive, but they're not square numbers, then you get 2 irrational answers, and irrational numbers are called surds. But they're still there, they still exist, but they're just not as easy to identify in the number line, so we use our calculator to just approximate it. Okay, so they're the ones, those cases are 2 intercepts. And then the case for 1 intercept is when the discriminant equals 0, and the case for no intercepts is when the discriminant equals a number less than 0. And the reason why there's none is because the discriminant is inside the square root sign, and for instance, if you have the square root of negative 11, it doesn't exist, so there's no x-intercepts. Okay, so copy and come across when you're ready. Okay, so now we're just going to work through a few examples, going through all the steps. So we start off with x squared plus 5x minus 14. Okay, the y-intercept is the easy mark. The number that doesn't have any x's, that's the y-intercept. And so ignore the x's, x equals 0, and so you're just left with a number. So that's the easiest mark you're going to get. The x-intercepts, this first one I've chosen to factorise it nicely because we're looking for 2 numbers that multiply to give minus 14 that add to give 5, so plus 7 and minus 2 are the numbers, and then we just take the opposite number. So plus 7 becomes minus 7, minus 2 becomes plus 2, because if the answer has to be 0, when we put minus 7 into that bracket, that turns it into 0, and when I put plus 2 into that bracket, that turns the second bracket into 0, so that's how I get a 0 answer. Now if I use the quadratic formula, I'll get the same answer, but just to prove that it did, I showed you all the steps, and then just to show that the discriminant was a nice number, the discriminant when I worked it out was equal to 81, which is a perfect square, so the answers were 2 rational numbers, which were 2 and minus 7. So you don't have to do both methods. Sometimes the quadratic formula is just as easy if you can't factorise quickly. Okay, so we're still in the same question. We've got to do a few more things. So the axis of symmetry is that minus b over 2a. So there's the b value. Okay, so 10 plus 5 into minus 5. And the a value was 1, so we've got it over 2a, which is going to be 2 times 1 is 2. And so that as a fraction is minus 2.5. But if you average the 2 x-intercepts, if you average those numbers, you get minus 5, which is the same as minus 5 over 2, which is the same. The turning point, which again is the xy coordinate. Okay, there's the x value from the axis of symmetry, and then you just plug it into the formula, y equals x squared plus 5x minus 14, and just let the calculator do all the work. And so then you list your turning point as a coordinate, and then you just make sure that you've got some level of accuracy. So you'll have grid paper. Don't forget to label your axes x and y. The axis of symmetry is an imaginary line, so I've just shown it with a dotted line. And then just make sure that you go through pretty closely those values, and then wherever it cuts the y-axis, you just label that as minus 14. So you don't have to worry about scale on the y-axis, because we're just going to show that one value. But on the x scale, you have to have some level of accuracy. Okay, so looking at next example. Y equals x squared plus 5x plus 1. The y-intercept is easy. You look at the number that doesn't have the x's, so that's the easiest mark you're going to get. Now the x-intercepts, you can't factorise it. There aren't 2 numbers that multiply to give 1 that add to give 5. But when you did the discriminant, the b squared minus 4ac, you can see that you actually get a positive number but not square number. So the answer is there's going to be two x-intercepts, but they're irrational. Okay, so the x-intercepts are there, but they're not nice. And so we use the quadratic formula because we can't factorise, and then we end up with these two answers here. So to get the two answers, it's -5 plus the number, and then -5 minus the number. And then just so you can see where they lie on the x-axis, I've just put them in as decimals, just so you can see where they approximately lie. The axis of symmetry, we're going to go back to the minus b over 2a formula, okay, just like we did before, and then plug it in to the y function to get the value. And I'll just jump it up a bit. So there's your turning point, and let's just join the dots. So you've got your your x-intercept, your x-intercept, your y-intercept will be up above, and there's your turning point, and just join it in a nice smooth curve. Okay, so copy that, and when you're ready, come across. Okay, so the next one is an example of okay, so we're just looking at another example where we've got no x-intercept. So the y-intercept, again, is the easiest thing. I keep saying it's the easiest thing because it is. The y-intercept is the easy one marker. The x-intercepts, you can't factorise it. There aren't two numbers that will work. And the reason is when you do the discriminant, when you do the b squared minus 4ac, you get a negative number. So once you get a negative number, you have no x-intercepts. Okay, so the axis symmetry, again, is that minus b over 2a formula. Okay, so minus b over 2a equals 1, so we finally got a nice number. We plug it into the y function at the front, at the top. We get -2, so the turning point is -2. And I didn't sketch this one. Okay, so we've got y and x. Okay, the only thing we've got is 1. So x is 1 -2, and so okay, it's negative there, so it's concave down, so that's -2. And so what we've got is a parabola. It goes like that, and then that value is -3. So it's an upside down parabola with no x-intercepts. Put arrows on both ends. You can see that the turning point is 1 -2, and the y-intercept is -3. Okay, try to be neat, not like my sketch there. Okay, when you're ready, come across the next slide. Okay, so we've got another method using completing the square, which we've done with a few different things. So previously, our first question we did today, that question there had a turning point of that value there. So what we do is, to complete the square, first thing you do is, well, first thing I did, sorry, was just move the -14 outside the bracket. And then to get the number that's missing, we halve the number. So half of 5 is 5 on 2, and we square it. Now, rather than putting a number on this side, I'm adding a number, so I subtract the number, and then I've got the same balance. So the -14 has just moved to the outside of the bracket, and whatever I've added, I've subtract because I'm on the same side of the equal sign, so I've got to keep the balance. So the perfect square is x plus 5 on 2 squared, and then -14 is that number, -6 1/4 is that number, so that gives you -20 1/4. And the easy part about this is, jumped up too high. Once you've got it in that form, just trying to change colours. Okay, the opposite number is your x value of your turning point, and then that number is the y value of the turning point. Okay, so you take the opposite number in the bracket for the x, and you take the number at the back for the y, and then if you're going to find the x-intercepts is when y equals 0, so then that -20 1/4 comes across the other side and becomes +20 1/4. To get rid of the square, you take plus or minus the square root. Okay, so plus or minus the square root of 20 1/4 is 9 on 2. You've got plus or minus, and then the plus 5 on 2 becomes -5 on 2. And let's see what we've got. And then, so you've got plus or minus 9 on 2, -5 on 2, and they get the same values. Okay, and then the y-intercept, I showed the y-intercept here, but it's obvious from the question that the y-intercept is -14. Okay, so it's just another way of doing it. It's actually quite quick doing it this way. And we'll do another example. So example 2, using completing the square. We're on the second last slide. So first thing I did is I sort of moved the 8 back, and then half of 2 is 1, but I have to square it. So I'm adding 1 squared, so I'm minusing 1 squared to keep the balance. So when we complete the square, I'm not putting the number over this side, I'm keeping the balance. So the perfect square is x plus 1 squared plus 7, 8 minus 1 is 7. So to get the turning point, okay, plus 1 is minus 1, and then that number just comes in as 7. Now, I've saved a little bit of steps, the x-intercepts. Okay, so that number, ooh, I made a mistake there. So, I've made a mistake. So, okay, when that, oh, sorry, I'll take that back. Okay, so when I've got, put my pen on, when I take the 7 across, okay, so I'm trying to find the x-intercept, which is when y equals 0. So the plus 7 comes across, so I've got plus or minus the square root of minus 7, okay, and then I'm going to minus 1, but these don't exist. There was no x-intercepts because when I took the 7 across the other side, it became minus 7, and you can't square a negative number, but the y-intercept does exist. The y-intercept is just the number at the back. Okay, so that last one wasn't quite as neat as I thought. The reason being is when you take the plus across, you get a minus, and you can't square root a minus because that would be what you were doing there. Okay, so on Moodle, in the resources at the top, there's a textbook called Essential Methods, sorry, and there's the exercises that we need to get through, and we've got to keep moving. Okay, thanks for that. Bye.